Hey, everybody. Welcome, welcome.
Hello, hello.
Let's see, we've got 9 folks. So I'm excited to have folks here. 14 folks. 15 folks. 20 folks. Kyle and I were just discussing our lighting. Apparently there's there's a Zoom setting to adjust for low light. So we were adjusting for the still rising morning sun in California where we are.
That's why it looks so good now. It looks good so before.
Yeah, Kyle's at Gatsby's office, Global HQ. I am in my place. Great, 26 people. This one's going to be a little bit, I think, smaller than usual. Wait another couple minutes. It's more of a technical deep dive, Q&A, no chat. Yeah, we seem to. I think. Let's see if we can get the chat to work here. No chat. People can ask questions. People can ask questions. I think we have not enabled chat for this one. Sorry, folks. But folks, if folks want to type something, type ask question, and I will read your question, I guess, along the way. 30 participants. We're a couple minutes past, so I think I'm going to get started. I'm going to share screen. Okay, here we go. Okay, cool. So great. So welcome everybody. Welcome everyone to this to the webinar. I think let's see. There we go. Welcome everybody to the webinar. We're calling this how reactive site generation works. And basically this is kind of a little bit of a deep dive into something that we've been talking about for just a little while, about 3 months, but that kind of encapsulates a lot of the advances that Gatsby has made as a framework, and it's also a little bit of a deep dive. So we'll get to that in a little bit. But so what we're going to be talking through is we're going to be talking through sort of some of the what is RSG, but some of the backstory, some of the benefits that you're getting from Gatsby's RSG, which is a rendering mode. We're going to talk about how we optimize for sort of like build performance in like an RSG world, and then we're going to kind of talk about we're going to talk a little bit about what's next. So to introduce myself, I think I should introduce myself. So I'm Sam Bhagwat. I'm Gatsby's co-founder and chief strategy officer. Here with Kyle Mathews, Gatsby's co-founder and CTO. So if you don't know us, this is who we are. And then I think a little bit about you. So again, it looks like chat is not working, but if you have any questions, feel free to pop them in the Q&A and we'll say hi. But first, why you might be here. You're curious about RSG, or like you're using Gatsby and you want to understand, well, what's the benefit of RSG relative to other rendering modes. You're curious how it works under the hood. This is a little bit of a deep dive, as I think folks might have gotten a sense from the email or the sign up. So if you're curious about how a platform as a service like Gatsby Cloud operates, and if you're considering building some of this functionality internally, which we kind of, I wouldn't say warn folks about, but we just kind of tell them it's a challenging road. And so we'll share a little bit of like what that road has been for us. Okay, so I guess I will turn it over to you, Kyle. Do you want to screen share, or do you want me to keep driving?
Yeah, keep driving.
Okay.
Yeah, so happy to be here. Yeah. So RSG it's both like a recent articulation. August, I guess, or July, whatever it was. What was it? July, I guess. Yeah. But it's really just like what we've been working towards for years since we started working on Gatsby, and the whole idea is running content sites, whatever the size, should be simple. Hosting should be a breeze. Security is built in, and everything's fast. Like, you just want to be able to like get preview, you want to publish, and all is kind of like fast and automatic, and it works with any backend. And so, and like I was saying, it's been a process getting here, but we really have arrived, and RSG is sort of articulation of like the principles underneath it and sort of the technical approach that we've taken. So this is a demo that I made for the blog post, which some of you might have seen, but yeah, we can watch it again real quick. And I'm here with Contentful, Anasite, and Gatsby Cloud. And like, this is not sped up. This is like real. Like, this is actually how fast it is to publish changes to your site. And it's like live on the CDN, et cetera, et cetera. Like, there's no way of publishing a site faster than this. And that's just a super nice experience. Okay, next slide. So RSG, publish content under 5 seconds is sort of the general product goal for the architecture. And yeah, so like I said earlier, we've been working towards this for a long time. The sort of the circle, red circle, is from 2018. This is on like a dev server, but this is like kind of illustrating like sort of the underlying pieces that have been in place to make this possible for a long time. Gatsby's data layer is all about hooking up arbitrary backends into the data layer, and then reacting to that to drive different things within the framework. And so here it's like this is a markdown file, and we're watching for file changes. And so like as we're typing in this thing, it's like re-rendering on the fly. So this is very similar to like code hot reloading, which I'm sure everyone's familiar with. We kind of call this like data hot reloading, where we can detect data change and then react to it to then reload, rewrite, recreate whatever the piece that the data is dependent on. And so in this case, it's the dev server re-rendering a markdown file into HTML. And in the previous dev, of course, was like taking that to the actual production website on the CDN that Contentful said, hey, data changed, we rebuilt the page, posted the CDN in about a second.
And this is sort of some of the backstory, because for folks here who were sort of like Gatsby users in 2018, this was sort of one of the first pieces of this that we shipped, because this was kind of running on the local dev server.
Yeah. So RSG is like intended to kind of have a sort of a best of both type approach, because the classic two ways of running a website are SSR and SSG. And probably most of you are familiar with sort of the trade-offs there, where SSG is like very simple. It's a very simple model. It's very simple to think about. It's kind of predictable, for better or for worse. And like hosting the site, scalable and secure, has great performance, et cetera, et cetera. So that's all great. Downsides, everyone says, is like SSR, or downsides to SSGs, sort of, and then the upsides to SSR is, what if your data changes a lot? What if you need to kind of quickly show updates, like kind of preview type scenarios, or anyways, or what if you need to like personalize the data, etc. So there's a lot of stuff where SSR is like rightfully people like it over SSG, and RSG is kind of like, okay, what if we kind of have the best of both, where we have sort of simplicity and the scalable, secure hosting performance of SSG, where you just sort of like don't even think about it, it just works. Like your site can't go down because there's no running code, etc. But it can also, your site updates instantly, sort of like rapidly changing dynamic data. And that's what, RSG gives you, is that, you can change your website every few seconds and RSG will keep up just fine.
Yeah. And the thing we hear most from folks who are building sites on Gatsby, the thing we heard most, a couple of years ago was, hey, can my build times be faster? And so, from a practical perspective, we wanted to help people with that.
Yeah. So, so again, going back to like, what is our goal at Gatsby? It's people building great content sites. We want to kind of help this be a lot easier. And RSG is like a big part of that, because a lot of maintaining a large content site is just changing the content. And if you're editing stuff, changing stuff, you're trying out different things, you're fixing mistakes, you're publishing new stuff. We have tons of sites on cloud with like dozens, hundreds of people editing the site constantly. And sort of having this like fast, feedback cycle, fast loop of data changing, publishing it really kind of helps make that process smooth. And along with, of course, great hosting, and the simple, fast, hosting that sort of the static approach gives you means that these sites are, very reliable and have great uptime.
And there's a lot of research that one of the things that is the best way of improving people's productivity is actually this fast feedback. There's a couple of photos that just sort of like illustrate that, and their answer is that, like, I mean, there's kind of this classic XKCD cartoon, right? Like, oh, I can't do anything, I'm stuck because my code's compiling, right? But I think we sort of see this in a lot of domains. So this is like I think a photo of, this is like a photo of content creators. It's Woodward and Bernstein reporting on Watergate, right? They're sort of like rapidly getting information, checking that information, feeding it back, writing it up, like that kind of thing. And then there's this quote from Brett Victor, which has always kind of been an inspiration as we've been improving build performance, which is that creators need an immediate creation to what we're making. And if your folks are familiar with sort of the life work of Brett Victor, it's kind of to create things that show a feedback cycle between in the programming world, and sort of to give visual feedback in a variety of different in a variety of different circumstances.
Okay, so there's a quick question break. So somebody asked, to what point could the need for dynamic fast changing data be fulfilled with React hydration after the SSG page has been loaded? How does SSR make this easier? So that's a great question. It's a little complicated. In fact, probably need like a diagram, because there's lots of types of data and there's lots of different scenarios. But yeah, so loading data in the client is often what you want to do for like sort of app-like scenarios. If it's like a dashboard or something, you log in and like the React app's already loaded, and then you can just like do an API call and pull it in. So many scenarios for sort of dynamic personalized data can be done from the client and work great in Gatsby, because Gatsby is a React app, produces a React app. Gatsby Cloud's dashboard is, of course, a Gatsby site. SSR is so RSG addresses sort of fast changing data scenario in sort of like the content world. So if you have data in a CMS and you're publishing, like a scenario would be, you have like a breaking news article, so there's just like lots of stuff coming in, and like, people are like keep modifying and republishing updates to the article. This sort of scenario where, you want to like publish it and then have it live almost immediately, because like, lots of people are visiting that page in order to get more information about, sort of the updates to it. Anyways, that sort of scenario, RSG is super nice. There is scenarios where, SSR is actually really essential. So the two kind of that really kind of plays like sort of A/B testing and personalization, because that you have a request and like you need to generate a page that's like very specific to that request. And so that level of specificity is great for SSR. Okay, onwards. How RSG works. Okay, so we're going to talk about SSG versus RSG pipeline, just kind of compare the two, because they're somewhat similar, but there's a key difference. And then how kind of the process works with content ingestion, incremental builds, incremental deploys, and how that feeds into how we kind of serve sites on Gatsby Cloud. And then last, we'll get into sort of performance monitoring optimization. So this is a complex distributed system that we built, and we've done a lot around sort of observability to both keep it running well, but also to drive a lot of optimizations as we've been building it and running it. Okay, on the go. Okay, so SSG, it's simple. Like it's sort of like it's a build process. Everyone who's a programmer has like built something before. You like run the build command, it does something, it spits out some files. Yay, I built something. Okay, feels cool. Everyone likes to build. That's why we're generally speaking, we're engineers. And so SSG is like, okay, let's compile stuff, let's build stuff, and takes that approach to a website. So you run a build command, it spits out a website. CI/CD, sort of continuous integration, continuous deployment process. We use that for a lot of programming stuff, and it fits very well again into sort of this sort of build a website paradigm of SSG, where run a build command, spits out the files, it's dumped on somewhere, and it's hosted, and it's great. And so SSG treats everything as a build. So you change the code, it rebuilds it. You change some data in the CMS, it rebuilds it. It's very simple. It just sort of does the same thing over and over again. RSG, on the other hand, it's like similar in some ways, where it's like it is a build process, but we distinguish between like code and like data build. So for a code build, it's very similar to SSG, where we just sort of rebuild the site, because like when you change code, typically speaking, that invalidates a lot of the site. So we kind of have to like rebuild a lot of things. But whereas with SSG, we're in different than SSG, for data builds, we do something quite different. Where with RSG, we kind of have like this like live data builder, which sort of can intelligently and sort of on the fly kind of like do sort of incremental builds of the site. So it can kind of like when data, there's sort of like a data update coming in, it can like very intelligently and very quickly just say, okay, this data affects these, n number of pages. Let's just rebuild those and redeploy those. And because it's sort of a live running thing, service, and it's just like heavily optimized the whole process, it can take less than a second to update these pages. Where SSG, because it's sort of like everything's a build, it's sort of like a fixed minute or two to make any change, whether it's data or code.
And you'll see a couple diagrams in the
so we'll be diving into a bit more. So RSG, what are the steps? There's content ingestion or sourcing, there's incremental builds, and there's incremental deploys. Okay, so what does ingestion mean? Gatsby has like a database that's attached to it. So like all kind of queries are run against the local database instead of like the remote source. So the first step in any Gatsby build is to sort of source or ingest the content from whatever other place into the Gatsby DB. So typically how this works is that, Gatsby Cloud is pinged by the CMS. You set up a webhook, says, hey, I got new content. That gets routed to the RSG service for that site, which then reaches out to, in this case, Contentful or whatever, whatever your data source is, pulls down the latest data, and moves on to the build step.
Okay, and I see a question here from Xavier Mirabella Montan. Is RSG provided by or part of Valhalla or complementary to it? Yes. A lot of the things that we're talking about here as part of RSG are also used in Valhalla. We can go in just when we get a little bit later, maybe at the end, just ask that again, and we can maybe go a little bit more into that if you're curious.
Yeah. Okay. So next slide. So so now we've done like ingestion of the latest update, like the sort of the synced copy of data locally is all up to date. Next is to rebuild the affected part. And so to do that, we do like dependency tracking is sort of the fancy term for this. So each time Gatsby builds a page, we track which data is used to create that page. So we sort of have like a table of like data and pages. So like, data 1 is used by these 2 pages, and data 2 is used by these 3 pages, and whatever. And each data can be used by multiple pages, and each page can depend on multiple pieces of data, and so on. So it's sort of a a end-to-end relationship. But anyway, so we have we track all that, and so then when data 1 changes, we can then very quickly say, okay, these 2 pages need rebuilt, yeah, and so that process takes like, it's just a very simple look at our data structure. It's very simple, and then rebuilding it, anyway. So this is all extremely fast. Like this can take literally like 100 milliseconds to, figure out which page to be built, run queries, build a page, and so on. So next slide.
And we built this sort of back in V2, but there was another piece that we sort of didn't.
So like I said earlier, it's like making this all take a second requires a lot of optimizations across both the framework and the cloud infrastructure. Like Gatsby Cloud is unique in that it's built specifically for Gatsby, for sort of this RSG paradigm. RSG is not just like, we've had sort of this like reacting quickly to data approach locally since V1, but taking it all the way, so it's like all the way through the process to the CDN, that like changing data means that your CDN is updated automatically, is something that we've only added in Gatsby Cloud and V4. And so incremental deploys, you might have heard about this. It basically was an optimization for how we sort of deploy stuff. And we moved from sort of a simple approach that we took first, which is kind of like very SSG-ish, in that there's sort of a folder with all of your site's files. And we moved instead to this approach where you can sort of like, you just have like a big pool of files, and you write out only the updated files into that, and they're all like hashed by the content. And then instead you sort of like a mapping, you store a mapping in a database of like which version of each files is, and so forth. Anyways, and this allows us to ship. Basically, it's a lot less work to deploy updates, because like in the past, there's a lot of like copying files around and writing to DBs and all sorts of stuff. And now it's very simple. Like if there's 2 files are updated, all you have to do is upload those, and then do one insert into a database, and then you're done. And that reduced the time to deploy by 10x or more for large sites.
But and sort of just to emphasize that, like the tricky thing is that you sort of have to move away from files and folders based paradigm, right? That we've sort of had with static site generation for time immemorial, and we're sort of in a new world here now, right? Like a ton of files in the pool, and in some ways we've had to change like the way that we serve files, right? Because you can't just point, you can't just say, well, here's a bucket with all the files in the correct folders, and that's what your site is. You have to now have because your files are in different, in one big pool, having been generated by different builds, and so you need this requires intelligent routing to know which files belong to which builds. As a backstory, Kyle and I have disagreed the correct pronunciation of 5 or 6 years. It's constant.
Router, yeah. Router versus router, I don't know. Yeah, so there's a lot into this. Richard's asking, is RSG available outside of Gatsby Cloud? And I mean, RSG is Gatsby Cloud. It's sort of a kind of, I mean, the point that RSG is basically, can you have a static build process that updates sites in less than 5 seconds is the goal. And what we build in Gatsby Cloud accomplishes this. Gatsby is of course open source. Other platforms could do the same thing. As of now, No one else is anywhere close. I mean, as part of the RSG blog post, if you look there, I did benchmarks comparing how fast the same site builds in Gatsby Cloud versus other platforms. And on common, places where people host Gatsby, it's easily 100x faster in Gatsby Cloud. And that's just a testament to, kind of the skill that we put into building this stuff. Okay, is SSR essentially an MVC, MVT model for server-side React? I actually really like building site ones with SSG as much as possible. Yeah, I mean, SSR is like, it's even simpler than like sort of an MVC. SSR makes really no assumptions. SSR is like, you have a process and it can render HTML. It doesn't make any assumptions about pretty much anything. It's a very simple low level construct. So yeah, but yeah, SSG is nice. SSR is like, it is very low level. So just sort of like, you have to build more stuff on top of it, which is fine. If you're doing something really custom or whatever, you want to control it all. But for a lot of use cases, it's just not worth the time to think about it.
Just historical backstory too, right? So it's like sort of since the web started, there's kind of been these two models like SSR and SSG, right? And so like if you in the 90s, if you had a PHP server, right, responding to requests, right, that's SSR. You also had like different types of servers or different types of services that were SSG, but they were sort of like that were generating files and were serving files. Those tended to be more niche, right? So these aren't sort of new terms. These are kind of oldish terms that are kind of
yeah.
Okay.
So, yeah. Onwards.
Okay.
Yeah. So why do we build this architecture? Yeah. Basically, I think it just kind of harks back to what we were saying earlier. It's like SSR and SSG both have very attractive properties. Ability to roll back to old site versions. This is sort of a SSG type thing that's like super nice. Like SSR, it's kind of like this, like it's a live thing. Like you can't just say like, hey, go back to how you were yesterday, because like there is no sort of concept of versions in an SSR site. It's just sort of like you're running the application. It is what it is. Where SSG is like, it's sort of like this like thing that's like, it's like a concrete thing that you can manipulate. It's like different builds of an application. You're like, what version of this of the build is this? And that's a very nice property for sites that you can if you have a mistake, you just like, well, okay, let's just go back to the old one. So yeah, so again, like, so these are things that SSG gives you, and RSG kind of preserves these while also pulling in the attractive properties of SSR, which is like preview support, instant preview support, instant publishing support, etc.
Yeah,
okay, next slide. Okay, yeah. So so that's sort of it's our explanation of RSG. Happy to take questions. We're going to talk a little bit about performance monitoring optimizations, because again, this is like a complex system that we built to kind of drive these sub 5 second publish times. Yeah, so just a little bit about like what we do as a cloud infrastructure provider to kind of both keep this running smoothly and no errors, but also like make it fast. So
just to add to some color too, it's like great performance is about sort of like your architecture, but it's also about sort of the ongoing maintenance of your system, right? And it's all about ongoing optimization, especially again to when your cloud infrastructure is one of the most complex kind of like pieces of the puzzle in terms when you're thinking about performance optimization. So it's one that is optimized. So
unlike Twitter, we don't make 1,000 RPC calls, but we do make 6 or 7 RPC calls for each publish. And so in a distributed system, it's sort of like, it's complicated because you're like, okay, all these things are bouncing around all over. And this is sort of a old problem. Well, it's an old problem that's just been like kind of gathering steam, because like more and more systems work this way. And what the distributed computing world has sort of arrived on as a solution to understanding what's happening in sort of this distributed world is something called distributed tracing, which is basically that, it's sort of like analytics for your distributed system, so that, anytime anything happens across all these, like you send some information to your tracing service, and then that service sort of like reconstructs the whole map of what happened. So it's like, it can start from like point A, branches out to 3 services, which branches out to like 5 other services. So you can actually like see sort of the whole journey of the request within your systems, and see exactly how long each piece took, and like, and all sorts of information. It's a fascinating kind of system and tool for understanding what's going on. Do you want to go to the next slide? So this
is probably overkill if you're like just doing, if you have a site. If you have like a complex SaaS app, like, okay, that might be interesting. And if you have like something like a platform as a service, like Gatsby Cloud, then you definitely need something like this. Yeah.
This is why cloud infrastructure, you do complicated things with like complicated tools, but we provide a great service you don't have to think about. It's sort of the trade-off here. But anyways, so this is a example, what's called like a trace of like a publish event. So this is somewhat randomly picked a site on Gatsby Cloud who published an update, and you kind of see like the different steps we were talking about, like refreshing source data is when like data gets pulled in. So it's like making API calls to some backend. It took 2.5 seconds. And then, rerunning page queries only took 0.2 milliseconds. Actually, probably means this one didn't run any queries. Okay, so this was actually, I think let's look at this example. But anyways, and then uploading. There was some change files, so uploading took a little under 300 milliseconds. And you can see kind of like the other API calls. And I did collapse that. So like the 58, for example, means there's like 58 sub traces that are part of this, which is kind of like bouncing around the different systems. So we're kind of like persisting different parts of like, so you run the build, there's like updates to both like files plus like data, and then we persist those in different systems in the backend. Yeah, and so like having this wealth of information allows us both to, whenever there's an error, we can like very quickly see what happened and fix it. Like we fixed like, in the process of like building the system, we fixed like hundreds of bugs. And especially once we started rolling out, they get very obscure. Like you run into a lot of them when you're testing, but in production, we have we basically set up an alert with Honeycomb that said like, anytime there's any error on a publish, alert us. And then this just revealed lots of very subtle, strange bugs. But because we have the system, we can figure them out, reproduce them, and then fix them. And now it's like almost 100% reliable. So it's brilliant for kind of like understanding strange bugs and fixing them, but it's also very helpful for kind of performance improvements, because it allows you to, a lot of performance is like the median performance is good, but sort of like the there's a lot of like, a small percentage of requests or actions are unusually slow. And Honeycomb lets you kind of query for those and like see what is the distribution like. Like if the median is 100 milliseconds, how fast is the P99? Because ideally it's not that much. I mean, it's always gonna be slower, but ideally, from the median to P99, it's like 2x slower or something, or maybe 4x slower. But you have a problem though when it's like the median to P99 is like 10 or 50 or even 100x slower. And that can happen for a lot of reasons. And again, like the being able to kind of inspect every part of the system allows you kind of like narrow that down. And so we could see like, oh, okay, like sometimes, this database select is slow. So like we need that index. Or sometimes, this request gets like stuck behind another one, or or maybe there's like some downstream service which whatever. I mean, there's endless reasons it can happen. But one of the things that we implemented is something called request deadlines. And the funny thing about distributed systems is that you make an API call and you don't know where it's going to go. So you could have like 20 different, services, or 20. There might be 20 instances of a service, and you're sort of randomly assigned to one of them, each API request. And the thing is, it's like, because it's sort of the randomness of load in distributed systems, occasionally one of the services will just like get a really heavy request, or just get like too many requests sent to it, and it gets slow. So what we kind of like figured out is that a lot of these sort of like slow P99 requests were just because they got sent to a service that was overloaded. And this is a very common problem. And there's a lot of literature published on this sort of type of problem, what to do about it. And one of the best solutions and what we implemented is something called request deadlines, which is basically you want to detect if your API call has gone to a slow service. And once, basically how you do that is you just say, give it a deadline. Like, this API request has to finish within X milliseconds. And then if it hasn't finished by that point, then you just restart it, which is like, sounds kind of dumb, but it's actually astonishingly effective because, like I was saying earlier, like ideally the difference between the median and the P99 is not that big, but in reality, it's often like there's like a huge, enormous difference between the two. And so even giving like a very generous deadline, saying like, say the normal, like the median is like 50 milliseconds, and you're like 500 milliseconds, that actually, it only affects like maybe 1-2% of API requests, but it can drop those from like, some of those were taking like 6, 10, 15 seconds. And it just meant that, you'd hit sort of that 500 millisecond deadline, and then the next one would typically then only take 50 milliseconds. So you're trying to dropping it from like, 6, 10 seconds to, the 500 millisecond deadline plus another 50 milliseconds, sort of the normal request at that point, and then on it goes. So anyways, it's a very cool, what do you call it? Kind of design pattern. And when we rolled it out, it made a huge difference. We're just sort of ensuring, again, like, not just because any system you want it to be bug free, but you also want it to be reliably fast, and request deadlines kind of help make that possible.
And zoom out to zoom out as well. Like, this is one of the sort of the many things we've kind of like done over time in Gatsby Cloud to sort of optimize performance and throughput in the system. Again, part of that was the architecture, but part of that is this sort of like ongoing, like, find the slow things, squash them, find the slow things, squash them, sort of rinse and repeat, over the course of months. And so, I think as front-end engineers, it's often we don't get visibility into sort of the cloud kind of distributed systems that can be underlying some of the things that we do. So I think like we wanted to share this as like as an example of like, hey, here's some about like how cloud service works at scale, as well as sometimes we talk to folks who are interested in like, hey, maybe we want to build something like this in-house. And again, we try to say something between like a gentle warning and like just give folks a little bit of an insight into some of the complexity that underlies this, that we sort of like, well, if you want to go down this road, these are some of the things you'll likely have to solve, especially like larger companies or enterprises.
Well, and I'd also say too, like, zooming out to the product experience again, it's like, why does this matter? Have fast, reliable stuff. It's like, the two experiences this drives is like preview and like production publishes. So like with preview, what are you doing? You're like changing stuff, and you're expecting to see the update like immediately. And so having like a very fast, very reliable publish experience is essential for preview, and same thing for publishing. It's like, you click save, and you just expect it to be there, you know. So again, like you click publish, you refresh, it should be there. If it's like most of the time there, you know, immediately, but then like 25% of the time, it just randomly takes 5 to 20 seconds. It's pretty frustrating. You don't really feel like you can rely on it, and so on.
So just kind of, you know, again, I think we have a conclusion slide, but those come to this very conclusion. You know, RSG is fast publishing for publishes under sort of like 5 seconds, even while serving serving files like HTML files rather than just hitting a process, right? We've been working on this for a while. It's, you know, it helps ultimately fast publishing helps content editors be productive and effective, and helps developers sort of be productive and effective as well. You know, we built a lot of these features into Gatsby Cloud, and excited to kind of share today a little bit about how they work. So yeah, I think that's I mean, you know, and sort of like, you know, RSG, we specifically talked about RSG because it had those 3 features. It had sort of content ingestion, it had incremental builds, and it had incremental deploys. And when we shipped incremental deploys this year, that's why we sort of are talking about RSG as kind of the combination of these 3 things together, along with sort of some of those distributed systems optimizations that you saw Kyle kind of walking through just now. So yes, that's it. I think, you know, I think this is a good time to sort of turn over to questions. So we have one question here from Avery Dante Hines.
Yeah, well, actually, let me. There's an early question about Valhalla and RSG. To jump back to that, you know, again, the idea of like RSG is like reactive site generation. It's like data changes, you react to immediately regenerating the part of the site that changed. And the cool thing is like with Valhalla is that we're sort of decoupling kind of this middleware piece, the data layer, the sourcing, you know, GraphQL API, etc., part of Gatsby, and making it standalone, which is both helpful for Gatsby, of course, because you know you can now query your GraphQL API in SSR. You can query it from functions. Those are kind of like key missing pieces that Valhalla kind of fixes. But also, of course, it's like you can now use the Gatsby API with any framework. It's like now just sort of a general middleware which is accessible to any front end, which is fantastic. I kind of want someone to make a WordPress site, like a headless WordPress site, hook it up to Valhalla, and then have a PHP front end, which is querying Valhalla for the WordPress data. So I think that'd be brilliant, and I hope somebody does it. But anyways, that was a little. So but yeah, so RSG, how like one thing we have been exploring is like how do we take sort of this like reactive site generation paradigm to any framework? Because what would be necessary for that is sort of the same sort of like dependency tracking, and then you know instant regeneration of pages, and so on. So we've actually prototyped you know that process, and it's something that we would love to make happen, because you know the whole idea is like what people want again is like you click publish and it's live. You don't want to have any delay in that process. That's just kind of like the mental model for you know any non-technical person. It's like the CMS is just a black box. They're like, I don't know, I put in text, I put in pictures, I click publish and it's live, and they get very confused when it's like doesn't work that way. And we want to make this sort of a simple deterministic process for any content site. Okay, next question. Oh yes,
let's get to Daniel's first. So Daniel asked a question about whether RSG can be used in Gatsby Cloud, and so RSG is right now it's only in Gatsby Cloud because RSG is content publishes under 5 seconds, and right now Gatsby Cloud is the only service that offers that. And there's another question about Gatsby 5. So Gatsby 5 adds additional optimizations such as slices. It also adds support for partial hydration in React 18. And
sort of, yeah. Gatsby 5 is awesome. You should update your sites. Cool. Okay, so yeah, Avery, what would you say is the most difficult or prevalent problem devs come across when trying to make advantage of RSG in older applications or websites? I mean, honestly, so the nice thing about RSG is that like Gatsby was designed from the get-go. So if you just have a Gatsby 4 or 5 site, it just works. Like you don't have to change anything to take advantage of RSG. And so yeah, so I mean, the main difficulty here is like it's like you have to. I suppose it's like you have to use Gatsby, and that's something that which there's obviously not every site in the world is built with Gatsby, nor will it ever be. So that's why with Valhalla we're kind of like extracting the best parts of the non-specific framework part, the middleware parts of Gatsby, like RSG, like the content layer, like the graphical API, and then making that usable with any application, any website. So if you have like an older application in the future, you can just use Valhalla and RSG and so forth.
Richard's asking a question about RSG outside of Gatsby Cloud, and your question is, if the CMS is hosted in Azure, you'd want to host the Gatsby site. You're saying you would want to host the Gatsby site there as well. So data wouldn't leave the data center. There'd be less latency and bandwidth. So here's the interesting thing about sort of the headless world in general, and the SSG or RSG model, which is kind of going back to this slide here, so in a little bit of how Gatsby works. So Gatsby serves files to you. So a lot of Gatsby has a local database that pulls in and sort of caches your content from sort of wherever it's coming, and then when the user comes in through the CDN, Gatsby is just serving files to you. So your data is actually already cached at the edge when you use Gatsby. So if you're sort of like thinking about like network latency for users, you don't need to worry about that because Gatsby's architecture already kind of solves that problem. I think it kind of, so they're
So I wouldn't worry too much about Azure to Gatsby Cloud slowing things down. Like that's one of the fastest parts, like of the whole process. Like most of the time, Gatsby making API requests to CMS is I don't know, like a tenth of the publish process or something at the most. So I won't worry about that too much.
Great. Yeah. Awesome. Other questions folks have? It's 8:48, so I think we'll, there's at least here in California. So if we'll wait maybe a minute or so for any other questions, and then we'll kind of. I hope everyone's enjoyed sort of this kind of. It's a little bit of more of a deep dive than we do usually. But we again, you can sort of read the blog post in terms of just to get kind of the basic sense of like, hey, here's RSG, and then we really want to share sort of like, hey, how does it work? To kind of nerd out over that, but also understand kind of some of the complexity that underlies like getting some of the complexity that you're kind of getting for free in some sense if you're running Gatsby on Gatsby Cloud. And some of the performance, the build performance you get for free. Okay, I'm not seeing any more questions. So thank you everybody for coming. It was super fun. I think it was super fun. As Xavier says, love the deep dive and would love to nerd out more. Yeah, that's glad to hear that. So thanks, Xavier. Thanks everybody else for coming, and have a great rest of your day. And I look forward to nerding out at some point in the future.
Okay, cheers. Bye.